Welcome to the Deep Dive. You send us the source material articles, notes, sometimes even audio clips like today, and, well, our job is to dig in and pull out the most important bits, the really interesting nuggets.
Exactly. We help you cut through everything and get straight to the core insights, maybe flag some surprising claims too.
And today, you've given us an audio source that tackles a topic that's, let's say, intriguing. It's about possibly detecting surveillance equipment.
Right, but not with super expensive specialized gear. The source talks about using really common, everyday things, gadgets you might already have.
Yeah, which is kind of the surprising angle here.
Yeah.
So our mission today is to unpack the methods laid out in this audio. How exactly do they claim these items work for detection? And maybe even locating a source.
It definitely makes you look at your own gadgets a bit differently, doesn't it? We're talking digital cameras, old radios.
Even your phone. So, okay, let's dive into this. So first up, the source talks about using just a regular digital camera, point and shoot, maybe even the one on an older phone.
That's the one. And the claim is pretty bold. It can detect electromagnetic waves associated with surveillance gear.
Oh, by listening, apparently, not looking.
Yeah, listening to the audio feed from the camera. The source specifically mentions listening for noise.
What kind of noise?
They describe it as a zip noise, a hum noise, a crackle noise, that sort of electronal interference sound.
Okay, so you listen for this zip or hum.
And the key thing, according to the source, is that this noise appears when you get close to whatever is supposedly doing the surveillance.
And it disappears when you move away.
Exactly. Proximity-based.
And the source kind of sums this up by saying it's a primitive way to prove that you're under surveillance. Primitive proof.
It is quite a claim. Using an audio sensor designed for sound waves to detect electromagnetic waves. I mean, electronics can interfere with each other, sure. You sometimes hear buzzing near speakers.
Right, like phone interference.
Exactly. But translating that into a reliable detector for hidden surveillance gear, specifically by listening for a zip.
Well, the source doesn't really explain the physics of how that specific interaction would reliably work, does it?
No, it just presents it as, hear the noise, find the bug, which, feels like a big leap without more technical detail.
Okay, so moving on from just detecting to actually finding the direction.
Yeah.
The source brings up a mid-wave radio, an AM receiver.
An old AM radio, like the kind you might actually find for super cheap.
Yeah, the source says about $5 on eBay, so very accessible.
And what's the process here?
Turn it on, but specifically during the daytime, and tune it way down to the end of the AM scale.
Where there are no stations broadcasting.
Right, just that background hum and crackle you get. Static, essentially.
Okay, got the radio, got the static, then what?
Then you use the antenna, you point it around the room, slowly sweeping.
Looking for something. Or listening for something. Listening for where the noise goes, as the source puts it. It implies the static or noise level drops significantly or changes when the antenna points in a certain direction.
Ah, like finding a null spot.
Exactly. And that direction, the source claims, is where the surveillance equipment must be.
Why would that happen? What's the reasoning?
The source says the surveillance device is acting like a mid-wave station itself, and the radio is receiving its signal, allowing you to find the direction by finding where that signal is weakest or strongest, depending on the antenna.
Okay, I mean, using directional antennas to find radio signals is a real thing, right?
Yeah.
Radio direction finding.
It is. But the specific claim here is that surveillance gear is broadcasting strongly enough on the AM band to be picked up and nulled by a simple, cheap receiver.
Which seems unlikely for most modern devices.
Hmm.
Don't they usually use much higher frequencies? Wi-Fi, Bluetooth, cellular bands?
Generally, yes, much higher frequencies. So the idea that a hidden bug is pumping out a signal that mimics an AM radio station. Well, it might apply to some very specific, maybe older or cruder types of devices, perhaps. But as a general method for finding any surveillance, it feels like a stretch. The source doesn't specify what kind of device would do this.
All right, next up.
Yeah.
Mobile phones. This feels a bit more 21st century.
Definitely. And the source makes a distinction between Android and iPhone here, which is interesting in itself.
Let's start with Android. What's the claim?
They mention a specific app, EMF sensor-free. EMF, electromagnetic field.
Okay, an app. Do you just run it?
Well, first, a crucial step according to the source. Turn on airplane mode.
Ah, right. To stop the phone's own radio signals messing with the readings. Makes sense.
Then, yeah, you scan around the room with the phone, and the claim is the reading on the app will increase when you point the phone towards the surveillance source.
So it's directional, according to this. And is there a specific reading to look for?
Yes. The source cites a range, 300 to 400 milligauss. That's presented as the magic number indicating surveillance.
Milligauss. That's a unit of magnetic field strength, isn't it?
It is, which is an important point. Phones often have magnetometers, compass sensors that measure magnetic fields. But most surveillance devices transmit radio frequency electromagnetic fields, not strong static magnetic fields.
So the sensor might not even be measuring the right thing?
Well, it's measuring something. But whether a high milligauss reading reliably points to an RF bug versus, say, just some metal or wiring or maybe the phone's own components, that's a big question.
And the source gives an example.
Yeah, finding devices up here in the ceiling in the apartment above me because the reading increased when pointing upwards.
So the conclusion for Android is quite strong then.
Very. The source says it can be used perfectly to detect that you're under surveillance and find its direction, which, given the milligauss versus RF issue, sounds optimistic.
Okay, so what about the iPhone side of things? How does it compare in the source's view?
They mention a different app. Tesla Meter 11th. Also sounds like a magnetic field meter.
And does it work the same way? Point and find.
Apparently not, according to the source. This is the key difference they highlight. They say the iPhone app does show a reading, maybe even a high one, like 400 milligauss in their example. But the reading stays the same no matter where you point the phone. It's not directional.
So you can't use it to find where the source is.
That's the claim. The iPhone cannot be used in a way the Android phone can be used for finding direction. It might show, quote, some kind of evidence that there's a lot of electromagnetic waves around you, although again, it's likely measuring magnetic fields, but finding the direction is nearly impossible.
That's curious. Why would there be such a difference if both phones likely have similar magnetometer sensors?
Good question. It could be down to sensor placement in the phone, software differences in how the apps process the data, maybe sensor sensitivity. The source doesn't really explain why, it just states this difference exists for this surveillance detection purpose. It's presented as a fundamental limitation of the iPhone approach in this specific context.
All right, moving on to the last gadget mentioned in the source. A heat-sensitive camera.
Yes, specifically mentioning the FLIR One accessory for the iPhone. And they note it's available for very little money, relatively speaking.
Thermal cameras.
Oh.
Okay, that feels more grounded in actual detection methods. Electronics generate heat.
Exactly. The basic idea is plausible. This device plugs into the iPhone, gives you a thermal view.
And the use case described.
Finding hidden devices by spotting their heat signatures. They give a specific example, checking a bathroom wash basin.
Okay, what did they find?
They describe seeing strange lights, which in thermal imaging means areas of different temperature coming from the sink.
Was there a significant temperature difference?
Apparently, yes. The source states the sink area was around 25 degrees Celsius, while the nearby walls were much cooler, maybe 16, 17 degrees C. And this was when the sink hadn't been used recently, so it shouldn't have been warm.
So the conclusion drawn was?
That this heat anomaly must be caused by a surveillance device hidden inside the sink structure. They even called the sink a very common place for hiding things, because it camouflages well. Using thermal imaging to find heat-generating electronics, that makes sense. If something electronic is running constantly, it will likely be warmer than its surroundings. Spotting an unexpected hotspot could indicate a hidden device. Whether it's definitely surveillance just from heat alone is another matter, of course.
But wait, there's apparently more to this thermal camera claim in the source, right?
Huh.
Something even stranger.
Yes. This is where it gets really unusual. The source claims this thermal camera setup doesn't just show heat spots, it also shows the direction of surveillance equipment through a different effect.
Not based on heat. Based on what?
Based on a visual artifact. They describe scanning around the apartment with the thermal camera past normal objects like a laptop, a light bulb.
And when the camera points towards the supposed surveillance equipment on a specific wall, something happens.
A pinkish fog appears in the thermal image, or described as a pinkish shine.
A pinkish fog in a thermal image caused by...
According to the source, this pink effect is caused by electromagnetic waves that are coming from the surveillance equipment.
Okay, hold on. Electromagnetic waves, like radio waves, are causing a visible pink fog on a thermal camera sensor.
That's the assertion. They even contrast it. Point the camera elsewhere, like the kitchen, no pink fog. Point it back at the surveillance wall, the pink fog reappears.
It doesn't sound like how thermal cameras or electromagnetic waves typically interact. Thermal cameras detect infrared radiation, heat. not radio waves directly causing visible color artifacts.
It seems highly improbable based on standard physics and how these sensors work. It sounds much more like it could be some kind of sensor glitch, maybe lens flare under certain conditions, or interference affecting the camera's electronics, rather than a direct directional detection of EM waves manifesting as a pink fog.
Yeah, that claim feels like the biggest stretch so far. It's a very specific and weird phenomenon attributed directly to surveillance EM waves.
So yeah, if we just kind of step back and look at all the methods presented in this audio source.
It's quite a range, isn't it? We got listening for zaps on a digital camera, finding quiet spots with an old AM radio.
Then using specific apps on Android phones for directional milligauss readings, but not iPhones.
Spotting actual heat spots with a thermal camera, which seems plausible.
And then that final, really strange claim about a pinkish fog on the thermal image, also indicating direction via electromagnetic waves.
What's really fascinating, or maybe concerning, depending on how you look at it, is this idea that everyday tech, stuff that's cheap or already in your pocket, supposedly has these hidden surveillance detection powers.
Right. It suggests these gadgets offer different ways to see or hear things that are normally invisible potential surveillance signals. The source presents these as ways to get actual indicators.
Specific things to look or listen for. Audio noise, a radio null, that 300, 400 milligauss number, a temperature difference, even this pink fog. They're framed almost like pieces of evidence.
And the source uses language like proving you're under surveillance.
Which really brings up the big question, doesn't it? If these are presented as ways to prove something so hidden and potentially serious, how reliable are these indicators?
Exactly. How do you actually verify that the hum you hear or the number on the app or the heat spot or especially that pink fog is definitively caused by hostile surveillance and not?
Literally anything else. Normal household electronics, faulty wiring, Wi-Fi routers, maybe just an anomaly in the cheap radio or the app itself.
Precisely. There's a huge gap between observing an unusual electronic effect and concluding it's proof of covert surveillance. The burden of proof there would be incredibly high in reality.
It really makes you think about what constitutes real evidence versus just an interesting, maybe unexplained observation. Definitely something to mull over as you encounter all the technology around you every day.